This lesson is going to wrap up official week 4 of online learning. Make sure you complete the electronic exit ticket for Module 5, Lesson 2, or knock out that additional 30 minutes of Imagine Math. As always, just check your tracker, and that will show you what work you need to be completing. Today we are going to continue with statistics and probability, specifically probability, and we're going to deal with estimating probabilities. But in essence, this is going to be a continuation of what we did yesterday. We are still going to work to understand probability and likelihood. We're going to work more on our mathematical vocabulary as well. Your goal, you'll have a different quizzes. You got to get 80% or higher, but it's still going to involve just basic probability concepts. So hopefully I'm sending you into a weekend with a good concept that you feel comfortable with, that you've mastered, ready to lead into week 5 next week. This is just a reminder. This was in Thursday's lesson video. Probability is simply the likelihood that something will happen. It ranges from 0, meaning impossible, all the way over to 1, meaning certain. Now, probabilities can also be written as ratios or fractions and percentages. So a certainty of 1 means 100%, for instance, or 1 over 1, or 6 over 6, or 9 over 9, whatever fraction. And impossible being 0 can be 0%, or like 0 out of 20, 0 out of 30, 0 out of 4, whatever form you want to write. Now, if something is half, like flipping a coin, that is a 50-50 chance. That is just as unlikely as likely, or neither likely nor unlikely, or it can be referred to also as equally likely. But anytime you flip and they're a coin, 50-50 shot, something like that, if you're pulling things like marbles out of a bag and there's the same amount of color happening, something like that would be in that 50-50 mark. Now, we're going to first take a look at this interactive spinner. Let's take a look at this spinner here in the scenario first of all. Marisol designed a spinner for a game. The spinner is fair if there is an equal chance for the pointer to land on each letter. Is this spinner a fair spinner? Now, if a spinner is a fair spinner, that means that there will be equal probability of landing on each part. In this case, these are letters. I see an A, I see a C, I see a B, D, and an E. So if it is an equal chance here, what that means is each letter amount should be covering the same amount of the spinner. I want to mention, like I did in the previous video, it doesn't mean it has the same number of sections. It means it covers the same amount of space. Now, we're going to select these sections to see the probability. And I'm going to work in reverse alphabetical order. So let's look at E. The probability of the pointer landing on E is 1 out of 6, or 1/6. Now, why is that? There are 6 equal sections here, okay? And only one of them is E. So the probability of landing on E is 1/6. Let's look at D. D is similar. So E and D so far make it an equal spinner because you have that equal 1/6 shot. Now, to be clear, that doesn't mean you are, as equally likely to spin D as anything else necessarily. It means you have the same likelihood of spinning D as you do E. C is also 1/6. I'm going to move a little quicker here. B is also 1/6. Now, A is 2 out of 6. Because you see there's 2 sections, equally the same amount of space, and there's 2 of them out of the 6 total. So the probability of landing on A is actually 2 out of 6. So this is not an equal chance spinner or a fair spinner in this situation because you have a higher probability of landing on A than any other section. So this, based on the question, is not a fair spinner. Marisol did not create this correctly. And it's not just the fact that A has 2 sections. It's that those 2 sections, when you put them together, are bigger or take up more space than B, C, D, or E. Okay? Because if I just cut A in half here and made this A down here like F, then it would be a fair spinner, even though A has 2 sections. Those sections together would be the same size as all the other ones. But this is not a fair spinner for that reason. We are now at the part of the lesson where I need you guys to pause, start taking some notes. So pause, write this down. Emir is going to spin the pointer on a spinner labeled with equal sections. So we're not talking about what we just did. We're talking about an equal fair spinner. A, I, O, and W. So if I wanted to draw this, let me draw something down here, and do my absolute best. I'm going to try to make this neat for you guys. I'm just going to split this into 4 equal sections. And what we have is we have an A, we have an I, an O, and a W. So this is what our spinner looks like in this, this scenario here. Now, what is the probability that the spinner will land on E? Well, I don't see an E here, so that's going to be impossible. That is 0 favorable outcomes, because the favorable outcomes are how many spaces are E, out of the 4 total. Now, that as a value from 0 to 1 is 0. That's the same as 0%. And we're going to attach vocabulary to this. This is impossible. The spinner does not have the letter E, so you can't spin it and land on E. That's kind of like common sense a little bit there. Now, what is the probability that the spinner will land on a letter that is in the word Iowa? Now, I'm going to first do my total possibilities. There are 4 possible outcomes here. You can land on I, you can land on A, you can land on O, or you can land on W. Now, all I'm going to do is I'm going to cross-check Iowa with the letters. If I land on I, that matches. If I land on A, that matches. O matches, and W matches. So no matter what happens with this spin, there is a 4 out of 4, or written as a value. There is a certainty, 1, which is the same as 100%, chance that this spinner will land on a letter that is in the word Iowa, because the spinner is actually made out of the letters in Iowa. So this is certain. It will for sure happen every time you spin, no matter what, no exceptions. Example number 2. Pause the video and write this one down. This second example is a very kind of common baseline probability question, which deals with marbles in a bag. That is a very commonly used probability type question. So, of the marbles in a bag, and I'm going to draw this because for me, and I don't know if you guys are the same, but it will help me visualize what's happening here. Let me make this a tiny bit bigger. So I've drawn this very, very simplistic, basic bag with these marbles in them. So we got 3 white, 4 blue, 4 yellow. That is a total of 11. You can get that from adding 4 and 4, 8, and another 3 getting 11. Or you can just count the letters. This is 3, 4, 5, 6, 7, 8, 9, 10, 11. So we know we have 11 total outcomes here. Even though there's 3 different colors, there's 11 possible marbles you could pick out. What is the probability that Sabri will choose a blue marble? Well, we know the total possible outcomes is 11. There are 11 total marbles. And blue makes up 4 out of the 11. Now, if I went to convert this to a decimal, all I'm doing is dividing because I basically wrote it as a fraction. So I can just convert that to a decimal through division. 4 divided by 11 gets 36 hundredths, but it's repeating, which as a percent is 36.36, and I'm going to repeat that percent. All right, so that's the percentage. Now, what vocabulary word describes the likelihood of Sabri picking a blue marble at random? Well, it's clearly not impossible because there's blue in there. It's not certain because there's other options. You could get white or yellow. it's not 50-50 because there's not an equal amount of blue as every other color, right? The only way this would be 50-50 is if blue would have to have half of the total number of marbles. So it is, I don't know why this isn't, there we go. It is unlikely because there is less than a 50% chance, or less than that value, okay? But it is not impossible. Anytime it is less than 50%, as long as it's not 0, it's going to be unlikely. It doesn't even matter if it's like 49.95%, or it's like 4/10. Like, if it's less than 50%, okay, it is going to be unlikely because the majority of the percent is made up by other options. Last example. Yes, this one is a little bit longer. So in your notes, when you pause the video and you're reading through this, if you want to paraphrase, that's always 100% fine. You just got to make sure you get the key points. So suppose you have a bag with 25 letter tiles. So we have 25 letter tiles in it, and 12 RV. Okay. All right. So that's about 50%. 12 out of 25, because 12 out of 24 is 50%, so that's pretty close. If you pick a letter tile at random from the bag, the probability of the letter V is 12 out of 25. So in our first bag, kill me with this color. In bag number 1 here, our probability of V is equal to 12 out of 25. Remember, you can write that P on the outside standing for probability. So that means probability of V. If I went here, back at this one, it would be written as probability of blue, like this, equals, and then you could say it equals the decimal, or you can say the percent or the fraction. I'm just going to write the decimal. But remember that P on the outside with parentheses means probability of whatever is inside the parentheses. All right. Suppose another bag has 300 letter tiles, so it's way more. We're scaling up, or at least the comparison is bigger. I don't know if we're scaling yet. And 96 of the tiles are V. Write the probability of picking a tile that is the letter V as a fraction and as a percent, and then from which bag are you more likely to. All right. Well, 12/25ths, if I just divide that, that gets a value of 48/100ths, which 48/100ths as a percent is 48%. So that original bag, that is unlikely. It is almost equally likely because you're close to 50-50 shot, but it is still below 50%. It is below a half. Now, for bag number 2, our probability of getting V is 96 out of 300. So just because there's more total V's doesn't mean it has the higher likelihood, because it depends on how many it's kind of competing with. It's competing, if there are 300 tiles and 96 are V, there are 204 other tiles in there. So we're going to divide this to figure out the percent, and I already know it's going to be less than bag 1 because bag 1 was close to 50%, and half of 300 is 150, which would be 50%. So this is not going to be that close. This is 32/100ths, which is 32%. So this is also unlikely. Now, to answer the question, from which bag are you more likely to pick a tile that is the letter V? Bag number 1 is more likely to pick a tile that is the letter V because the probability is closer to 1, even though there are more V tiles in the second bag. It doesn't matter how many total V tiles there are. It's a combination of how many V tiles in comparison with the total number of tiles. Just want to be 100% clear with that. Because if, say, right, you had a bag, and there were 25 total tiles, and all 25 were V. You're going to pick V. If we have 300 letter tiles, and 272 of them are V, you still have a better chance of picking V in the 25 tile bag because that is 100% certain you will. So with probability, it's not just what is more, it's how does that amount compare to the total amount of outcomes. Just a reminder of what probability is. It's a likelihood that something will happen on a scale from 0 to 1. 0 closer to being impossible, and closer to 1 being more certain that it will happen. I'm going to also put this link in today, Friday's assignment, in case you did not watch it last time, but you're still struggling, or maybe you're starting to struggle. Please use this resource. It's a pretty solid video that will explain probability if you feel like these first 2 videos of this module haven't been specifically helpful. Last assignment, in addition to whatever your homework assignment is for this week, you're going to go complete a Quizizz, so no Edulastic assignment this week. The Quizizz is titled Estimating Probabilities. It's going to be very similar to yesterday's. We're trying to build that very strong foundation, so when we get into more complicated probability problems, you guys are set up for success. So knock that out. Make sure your tracker is complete for the week, and then once you're done with that, once you're done with all your classwork and homework in your tracker, enjoy your weekend, and we'll check back on Monday.